Hello everybody, Matt Highway speaking. Today's little short episode is around this great tool called Landscape DNA. Now this is the brainchild of scientists at Land and Water Science and was developed, as far as I know, through our Land and Water project. It is several years old, but it still has a lot of relevance, particularly for catchment management, and you'll see it has so much information and useful things in here. It really is the go-to portal for a bunch of things, particularly around education, around how our water and water chemistry interacts with the landscape. This is the homepage of Landscape DNA, so it's just landscapedna.org, and straight away it gives you a whole bunch of things that you can go and look at. The science, the scientists that develop this were really keen on being able to educate people as well. I think it's just like LAWA is, it's not only an information tool, but a great place to educate yourself, and I find it super useful. So there's a whole bunch of sciencey type things in there. We can have a look at actions as well. So while this isn't all of the actions and isn't necessarily kept up to date with some of the more recent technologies or emerging technologies, should I say, there is a whole bunch of really well-proven, well-researched actions that you can take. So really cool. It's based off published papers, and you can really just explore this in whatever detail you would like. This wonderful little tool down the side here, a contents page, essentially takes you to the right place for the right reason. And the information is there, and all the references related to the work too. So the main thing though I wanted to show you was, if we go back to our homepage here, we can look at our maps. So this is, a lot of it's based on the physiographics work that Lisa and Clint did initially for Southland, and then also for the rest of the country. So a really cool piece of work, which looks at lithology, I suppose, the geology, the soils, the slopes, the rainfall, a bunch of those sorts of things. So how they've set it out from a mapping point of view is physiographics first. We can look at a whole bunch of other sorts of things as well, and these are these physiographic units. I'm not 100% sure of the scale. It will probably tell me when I click on here. No, it doesn't. A lot of these are 1 to 50,000 scale. This might be even bigger by the look of it. But the cool thing is, no matter where you are, what sort of catchment you're in, you can click and it will give you the information based on that physiographic unit. And of course you can dig more and more into detail on these sorts of units as well, and there's information on the right hand side about that. So it's really useful sort of thing. You can dig a little bit sort of deeper on what they've called these sibling classifications. So it's a little bit more technical, I suppose, so about how the landscape behaves. And again, it's really useful to go through a whole bunch of other things. So remember, this is how the land use independent, really. It's how the landscape behaves. So it's such a great way to describe a catchment, how it behaves and why it's different, so that we don't, like a lot of the stuff we do as catchment managers, we don't start pointing at certain sectors, forestry, or hey, it's dairy's fault, or sheep and beef, or hey, it's those urban people. It just really shows that we're in this catchment context and that we've all got a part to play, and the landscape is different and it's driving a lot of the behavior, particularly from a water quality point of view. So this is strongly focused on water chemistry, of course, and the interaction with land and soil, not so much on biological outcomes. So it has its limitations, of course, too. What's really great about this map is, we can look at a whole bunch of other things. So let's go into hydrology. We can go into something like overland flow risk. So this looks at, of course, the underlying data around, how well drained it is, what its slope is, how long its slopes are, those sorts of things. So we can start to have a look at sort of more useful information. So, here in this little catchment, we've got highly likely to not go through the soil or subsoil. It's going to be the rain is going to be hitting the ground here and running off. And this could be integrated with current land use as well, most likely, like if there's roughness or vegetation there, more likely to infiltrate the soil. But as you can see, it's just super useful. If we click on here, we've got quite free draining. So when we've got water running through this flat valley, it's going to go into the soil pretty quickly rather than overland flow straight away. Whereas if we click on one of these red areas, it describes it over here, which is really great. So 32.2% of annual rainfall is going to be runoff. It's heaps, right? And it talks about the slope, all the challenges around it, we're all backed by science. So this super cool, really defendable, and across the country it's the same. Let's have a look at another thing. A whole bunch of things you can look at here as well to go into more depth, I suppose, around hydrology. Things like lateral drainage, natural soil bypass is another good one. Once it loads, you can see this is very unlikely to bypass. Chemical processes, this will be quite an interesting one. So obviously the land and soil operate differently together, and we've got the soil reduction potential, which means a lot of things sort of chemically. From an operational point of view, what I like to think of with this one is its ability to denitrify, I suppose. So this one's in the middle. If we click here, it's pretty low. This is our free draining kind of soils. So unlikely that it's got enough organic carbon to help denitrify, and further up in the hill country in this regard, we've got some opportunity to do that. So, looking at this, potentially intensive agriculture on these areas with high nitrates could be a challenge, depending on the receiving environment, of course. But let's just zoom out as places where we do know we've got organic carbon, like around Hamilton. Here we go. Peat soils, let's click on that. Yep, soil reduction potential really high, because we know that this is peat soil, so really high organic matter. And you can see that these are also quite high as well, big basins of peat. And we've got that throughout the country, of course, but predominantly in the Waikato. Okay, let's go back down. One thing, like we might want to kind of further investigate, let's go back to hydrology and look at groundwater. Deep drainage, let's have a look at that. So we've got, go back to our catchment, here we go. We've got deep drainage occurring in plenty of these places. And if we click, we've got moderate and all the way up here, somewhere in between as well. Water table depth will be an interesting one in this catchment. So let's say we already know that we've kind of discovered that we've probably got free draining soil. We've got low incidence of overland flow. So if we click on this one again, depth of water table, geez, only 0.2 of a metre, 1.2 metres. So it's likely to go through, nitrogen's likely to go through the soil and hit that water table pretty quickly in these areas. So it's, things like that, like it's a great thing to investigate. It's kind of useful, right the way through. There is, the last thing I'll sort of show you, and I think this is quite cool as well, and one thing I use quite often because it's just such an easily accessible tool, is this rainfall map. And it gives you the rainfall data, probably from NIWA, in different parts of your catchment, so you can really see what's going on, or your region. So you can see along the ranges here, the Southern Alps, we've got a massive amount of rainfall, 6.5 metres. Right the way through to in here where we've got only 1 metre. So you can see the variation really quickly and what might be happening. So if your catchment is in something like this, short and steep, then that's obviously going to change the hydrology or how you might be impacted by storm events. But like I say, this is just such a nice way to access that data compared to other portals, I believe. So there's a bunch of other things in there. I'd suggest you go in and have a look. It's super cool. Temperatures. Certainly not feeling hot today where I am, but here we go with annual temperatures. So I am up here. 14 degrees, there we go. Mean annual air temperature, so that's the daily maximum. So like I say, go and have a little look. It's really interesting. It has those wonderful kind of links into the science and some of the actions, and it'll make the link in between your landscape, wherever you are, and some of the things you might be able to do about it. It's not perfect from a catchment planning point of view, but it's super smart. It gets us speaking the same sort of language, and it's based on great science. So I ask you to just go and have a play around and see how you get on. Okay, thanks. Take care. Bye.